Hi, it's Jan Beta, and what I have here is something that Bwack, or Hans, sent me quite a while ago, and yeah, basically I procrastinated putting this together and making this video. I planned on doing this for quite a while now. What it is the switchless kernel switcher that he developed for the Commodore 64, which is basically, you can put an EPROM in here, 27265 one, that can hold 4 different kernel ROMs for the Commodore 64, which you can then switch by either resetting the Commodore 64 or pressing the restore key. And he made a very nice and very informative video series about the whole process of building this and developing it, which I will link in here. There's so much to learn from him. He's basically one of the few people in the business of doing old computer stuff that know this stuff, really. And he's basically, most of what he does is pure magic for me, from my perspective. So a lot of it is much above my scope of things, but yeah, he's a wizard, basically. So check him out if you want to learn about this stuff. It's very, very interesting what he does, even if you don't understand all of it. I have learned a lot from him, from watching his videos, and he's a very nice guy as well. And I want to say thank you, of course, for sending me this for free to try it out and to make a video about this. And yeah, he also sent me 2 of the PCBs he had left over, so I can you can use these as an adapter for using EPROMs on the sockets in the Commodore 64. Yeah, what else to say? Let's put this together, I'd say. So and here's a little pig that is programmed to do the magic that's happening here. The rest of it is basically an adapter from the 28-pin EPROM to the 24 pins that the Commodore ROMs have. And yeah, he also sent a little... What it also does, which is a fun thing, I think, is it has this is an RGB LED, which can change its color, and you can the plan is to put this instead of the normal power LED on the Commodore 64, so the color of the LED designates which ROM you have switched to, which is a fun idea. Okay, so I think the only things I need are some resistors and a little cap. So let's solder this up. The only specialty is, I think, is the little pig goes on the bottom side of the board. And yeah, otherwise it's pretty straightforward, I think. And you have, of course, 2 connection lines for, where are they? Yeah, reset and restore. These on the bottom here, to the reset circuitry and to the restore key circuitry, which is has little special circuitry inside the Commodore 64. But we're gonna look at that in a bit. And I will also link the GitHub repository Bwack made in the video description, so you can download the bill of materials and the circuit board to have it produced. And yeah, basically the video series he shows how he developed this, so it's probably easier if you want to build this to just go to GitHub and download and also there's also the code you have to program into the pig. This one is pre-programmed. I checked it before, so thanks again for pre-programming the pig. I would have been able to do that myself. I have an EPROM now, so that is able to do it. The same that Bwack uses, actually. So okay, let's solder in some components, I'd say. Okay, so this is the basic assembly, I think. And to clean this, I'm going to use my new electrostatical approved super safe brush, which Thomas donated to me because he saw me using these toothbrush things all the time, and yeah, they're not very safe for working on electronics because they are made of plastics, and plastics can be can cause electrostatical buildup and then destroy your electronics basically. And there's a pig on here that could be destroyed. So I'm being a bit careful. Okay, so I am going to program my EPROM now, and I have chosen 4 ROMs. There's actually 5 in here. I've chosen 4 ROMs to use. One of them, of course, being the original ROM. You can find these all over the web, basically. This is nice. This is the most common one. I think it's also the one that is in the Commodore 64 originally that I'm gonna put this in. Exos is a German fast loader kernel replacement. That's, yeah, it's very good. Was very broadly available in Germany back in the day. And there were many machines with Exos in them. Datal Turbo ROM, I don't know anything about. I just put that on there because I think it's pretty good. So I want to try that. Can always program new EPROMs with new ROMs on them. So this is the famous one, Jiffy DOS. And Jiffy DOS is still on sale, so it's illegal if you don't buy it to use it. It's available from Retro Innovations. Actually, I will link that in the description so you can buy it. I think it was $8 or something like that. So yeah, it's very pretty much you can buy the Commodore 64 ROM, and you can also buy the ROMs for various other machines like the floppy disk drives. You always need another counterpart ROM in there to use Jiffy DOS on these machines. Gonna do that later. I haven't bought one yet for the 1541 I have. This works on the SD to ISC cards and stuff like that as well, so it's enough to have one for the Commodore 64 if you're only using an SD to ISC. So okay, let's make our EPROM file. I showed you how I did this before in my Atari video. I'm using the copy B, copy/B, which is binary. And then you can basically just pull them in here. Make a plus, space, and then Jiffy DOS, Exos, and Datal Turbo ROM. So, and then another space, and our output file name, which will be 64 Kernal Switch bin. Okay, it made a new file there. We are going to find, no, I'm wrong again. There it is, 64 Kernal Switch. So this is our bin file we are going to put on our EPROM. And it's 32K, of course. And yeah, that's the exact number, always check that. You can also put these together in the Mini Pro programmer software, but it's, yeah, you have to take care that you have the right starting positions there. And it's a bit more difficult, I find. So I need an EPROM, I think. I need an EPROM. As luck would have it, I have a one of those here. And put it in there. And then, yeah, let's go back to the screen. So I have my AMD 27C 256, of course, in the DIP28 package, dual inline package. Select. Now we can make a little blank check. It's always good to know. Oh, ID error. Okay, these have the wrong ID for some reason. I had that before, so you have to disable the check ID field here. But most of them worked. Blank check. Seem to be a slightly different revision or something like that. Okay, the device is blank, so we can load our file. 64 kernel internal. Okay, so there we have our. And if you wanted, there's our Commodore 64 basic. You could also go in there with the hex editor or stuff like that and mess around, but I'm not gonna do that because I want to keep things as original. There's our error messages and stuff, and oh, yeah, you can basically see the whole stuff in there. Okay, so let's program this and try it out in the Commodore 64. Program. Yeah, this seems to work. Sometimes the old EPROMs, I got a bunch of used ones, and some of them don't work very well. So, but this one seems to be fine. Programming successful and verified. So that's that. Okay, so now we are going to put this into the Commodore 64, of course, because otherwise it wouldn't make no sense. I'm a big fan of keeping it as original as possible, so I'm not even sure if I'm going to use the LED thing. The good thing about this switcher is that you don't have any knobs or switches outside and don't have to drill holes into the case and stuff like that. So you're going to keep this original and you're going to switch it by pressing restore or resetting the Commodore. So that's nice. And yeah, let's try this. So what I'm going to do is to get rid of the shielding thing here finally. I didn't do it because I wanted to keep it original, but it absolutely makes no sense to keep it in there because it's just shielding the surroundings from the RF that the Commodore produces, which it doesn't matter much to modern electronics, I think. So yeah, that's going to go away. There are two connections here, reset and restore, and these go to certain points on the PCB. So the restore goes to this is R41, the little resistor on this end. I marked that, and I think the reset can go here to R36. And yeah, the reset basically, after you push restore for a longer time, the reset line is triggered. So the system switches the ROM position to another bank of the EPROM, and at the same time resets the computer. So the new kernel is going into effect. So that's the plan. And yeah, let's see if we can get it to work. I'm going to solder in some wires and... So this one is the kernel ROM, this one, 901227, revision 3 in this case, is the last Commodore 64 revision, the last Commodore 64 kernel revision, which hasn't changed ever since. This is 1983, I think. So let's pull this out. And then basically put this in. I think I put some tuner spray, contact cleaner in there, because these sockets are sometimes a bit of a pain to make contact in an appropriate way. So I think I have to bend some of these a bit. Seems to fit. That's good. That's a good sign. Okay, let's connect the wires there. I'm sticking in the EPROM there. Ah, nice. Fits nicely. So I am also connecting the LED now. I don't know if that makes any sense, but it is connected to the circuitry there. So I'm going to connect it anyway. There we go. And then we'll add some heat shrink stuff over there and connect it. Okay, let's test this, I guess. So I got it partially working. I'm just inserting the LED here, I think. So it doesn't reset, sadly. If I reset it externally, it works fine, and it changes the to the blinks, and then I can switch between those. So I think I'll try to put the reset wire directly on pin 3 of the user port, where there's reset 2. Could also put it on the processor directly. There's also a pad coming from there, but I think I'm going to try the user port first. Maybe that works. Okay, I stuck the reset line directly on the user port now, so let's see what it does. Let's see. It's not resetting, is it? I can switch this and then I can switch it on and off, but that's, I don't think that's what it's supposed to be. This works no problem, so this should be the original basic now, which it is. This should be JiffyDOS, which it is. So yeah, it just doesn't reset itself. That's a bit strange. I don't really know what to think of that. So here's how this is supposed to work. I press the restore key. The LED flickers after a second, and I can switch through the ROMs. And then I choose one, like the blue one, and it should reset and thereby start the kernel. But it doesn't reset. So I did set up my scope to troubleshoot, and I think I kind of found out what's going on there. I don't know if I can show you this. Let's try. So I made a ground connection here for the ground of the probe. Connect that back. And I am going to stick this on the reset line there.
should be clearly visible. If I push the reset button on my final cartridge here, you can see, oh, I have to put this to AC. So it is high, and if I push the button, it's pulled low. So that's the reset line that and it works fine. The kernel switcher should listen to that reset line, and you can maybe see I don't know if you can see it at all, the LED changing there. So I hold it, and it should react just like the restore key, which it does. So I'm switching the kernels. You can't see it because I have my final cartridge inserted, and the final cartridge overrides the kernel, basically. So that part works. Now, if I press the restore key, this line should go low. Yeah, this line should basically be pulled low. But yeah, let me show you what this does. So I'm pressing the restore key here to find it. So and it does, but only for a very short time and not as low as it's supposed to, I think. So there is something working there, but it might not be enough. I don't know why this is, so maybe, yeah, I just don't know, really. It's not sufficient to reset the computer, apparently. So it does a reset, maybe, but it's just not enough. Yeah, so this is halfway working now. Apparently, I contacted Bwack about this, and he pointed out that it may be the PIC that's broken, the little controller chip there. That he sent one to another person, Disco HR, who also commented on some of my stuff. And yeah, Disco HR apparently built another version of this switcher for the Commodore 64C, I believe, for the shortboard versions of the Commodore 64. And yeah, he has his own fork on the GitHub thing there, and yeah, basically it's another slightly different program and stuff. And Bwack sent him a PIC and the little circuit board, and the PIC was broken for him. So I don't know what the exact things that happened were, but at least the PIC, they seem to break sometimes. So maybe that's the case with mine. Everything else seems to work. I checked the connections on the circuit board. Seems to be all according to plan. Yeah, I don't know. I'll probably end up using the other board I have and ordering a couple of those PICs and soldering this up to work. And maybe this will work. So it is a couple of days later. And apparently Hans, Bwack, sent me some new PICs that he bought from a reputable seller, so to say. So I guess these are original ones. He believed, I contacted him on Twitter, and he believed that the PIC is the thing that's the culprit for the switcher not resetting. Okay, got my programmer here and my trusty Windows XP installation. And yeah, I'm gonna search for the PIC here. It is 12F629. And there's no dip package here, so just take the standard, I think. And let's select it. Okay, the EPROM's in. Give me a second to set this up and connect the power supply and stuff, and then we'll test it. Okay, so I am giving this some juice. The monitor is running, and let's see what it does. Oh, and as you can see, it does absolutely nothing. And it shows the usual Commodore 64 basics, so that's okay, but doesn't switch anything. So I probably misprogrammed the pig, which is a pity. Okay, so here's for the second try. And it doesn't work at all. Oh, dang it. So, it is quite some time later now, couple of days, maybe weeks, and I finally got this working. I found out that I programmed the wrong file onto the little pig with the new pig I got from Bwack. And yeah, I made the stupid mistake of downloading the GitHub file with the right click rather than downloading the whole archive. The right click gave me an HTML file or an XML, I think, without the extension, the file name extension, so I didn't realize until too late. So what I did, I'm not going to show this again because it's pretty... If you download the right file, you have to download the whole archive and yeah, unzip it, and then you have the little hex file, and you just use that, and it has the right size, and you can use the Intel hex setting in the software and just program it on. And yeah, so what I had to do was to desolder the chip and resolder it, and yeah, it was quite some effort, and I messed up a bit, and yeah, that's what I ended up with a little little circuit board that had broken traces and stuff. So I just I scrapped this, and I'm gonna use this as an EPROM adapter. And yeah, what I did was to use another board and solder in the components just like you saw, and now it works. And let me show you how this is supposed to work, and it even looks different on the LEDs, so watch. So I'm depressing restore until it flickers, and then I can switch through the little systems here, and then it resets, and that's what it's supposed to do. So I got this pretty nifty little hack for JiffyDOS that gives you the key commands and the built-in monitor and stuff from DolphinDOS, which is a pretty nice system that I used back in the day also, that I also have on the EPROM here. Yeah, so basically this is how this works, and now it does. And here's the original Jiffy I want on here, and of course the original Commodore 64 basic. But I ended up using this mashup version here quite a lot because it has a beautiful colorful screen, and works quite well with the SD to IEC because it uses the fast loader routines of JiffyDOS and all the shortcuts and stuff from DolphinDOS, which is a nice mix, I have to say. So anyway, just wanted to add this in the end here. Thanks for watching. Thank you, Bwack, for sending me this. Sorry that it took so long, but maybe you learned something from my mistakes also. Hope to see you again on this channel. If you want to support me, check out my Patreon. Oh, sorry. Check out my Patreon. And yeah, basically give this a thumbs up, comment on this. You can get these from GitHub. It's all open source, open hardware. You can make your own circuit boards. Yeah, so spread the word, spread some love. I'm Jan Peter. See you next time. Bye.